Okay, so hello everyone, dear all participants. Today is a another wonderful moment which we are going to enjoy a lot. Not only that it will be informative, rather they are the luminaries and super experts from Cisco Group. So in fact, Lakshmi, I have heard a lot from about you from Girish, Rajesh, and your whole team. So we are really thankful and happy that you are an Indian asset to India especially, right?
Oh, thanks.
So this is really good. So today, dear participants, Lakshmi ma'am will be talking about MAC address randomization for IoT nodes. As such, MAC address randomization itself is a major aspect. We typically talked about IoT nodes because once IoT nodes could be identified where they are and how they can be accessed, it may add to lots of vulnerability, right? So since we are typically talking about application aspect of the next generation networks for data analytics and predictive technology based applications, this will come handy. So regarding Lakshmi, she has been in fact an altruist. She has been working for the society a lot. She has been working with Cisco for at least 20 plus years, developing microcontroller based networking platforms. And she has been leading the routing and forwarding group with developments of features like NetFlow, BFD, ISU, BGP, PIC, LISP, software defined access, of course. In fact, these are the features that are especially boasted by Cisco as technology. They are also pursued in open source domain. So these are the technologies of highest importance, and we are happy that she leads that team. Uh, she had also been focusing on SDA design, deployment, and next generation enterprise platforms to provide the features like network secured access, EVPN, VXLAN, and SDA security policies, secure fabric, and currently she is pushing MAC address randomization even to next levels. So we formally welcome Lakshmi Mukund from Cisco for delivering a wonderful talk on MAC address randomization. So we welcome you all and we welcome Lakshmi as well. So the stage is yours. Lakshmi, please go ahead. And
hopefully now it'll be okay. Let's
yes.
hope.
Yes.
Again,
Yes.
thank you so much for the wonderful introduction, Professor, and especially thanks to Girish and Rajesh for helping organize this whole thing. So this is this is a topic very close to my heart, and I'm working on it currently. So you can interrupt me at any point in time and ask me questions, make it interactive, right? So let's. This is my agenda. It's all going to be about privacy and security, right? Two very important aspects because I think we should respect privacy, and with privacy comes the question of whether we can still provide that kind of security that we could if we knew who we were. But still, that's also important. And how does this whole MAC randomization come into the picture and the repercussions of randomizing MAC, the solution, standardization, all of that is going to be here. But let me start with a kind of related story, not totally, but this one is a map actually. Strava is a company which collects information from all your Fitbits, Fitbits and your health devices. They are fitness trackers. You can wear them and go for a jog or a walk or a run and it'll track you, right? So I found this story extremely interesting. So this app kind of tracks all the different people around the world, whoever are using Fitbits at some point in time. This is how the map looks up, right? So if you see here, all these lit up areas are where people are actually exercising at that point in time. Now, what was interesting was somebody took this Strava gives you the map of the whole world, really. So somebody kind of zoomed in And they found that in a place where there's absolutely no lights at all, like this, they found some, specks of light here in areas where it was like completely dark. And it was in Afghanistan. And they were like, who is wearing a Fitbit there and, walking around? Then they realized it was a very top secret US military base, right? So we have something as simple as a Fitbit. Some soldier is wearing there, running, just doing his regular thing. And it turns out it's it gave way to some important information. It was more than interesting. I thought it was extremely funny. So like this, we don't know how information that we have, it can be kind of used, misused, interpreted, misinterpreted, right? So I think whatever it is, the data that belongs to a human, a person, is completely private, and it is only up to that person to be able to allow that information to be shared on. Is there someone saying something? They forgot to mute.
Everyone, please keep your microphones muted.
Okay. So,
Lakshmi, you can unmute yourself now. Yeah, just unmute. Yeah, perfect.
It's okay now, right? Okay.
Right.
Okay, so let's have a quick recap of the networking layers. All of you are very familiar with it, the physical, data link, network, transport, and the rest of the presentation layers. Now, if you look at data that is coming in from your application, it gets encapsulated in a transport layer, which is typically either your TCP or UDP, depending on what connection you want. So you have the TCP and UDP port numbers. After that, it gets encapsulated inside an IP packet, which also has an address. So what I'm trying to indicate here is every layer has to have an addressable set of pattern, right? Because only with that address is how the layer will identify to which device in that layer this packet is destined to. So this is the IP address, which is here. And then we have like the data link or the layer where we have the MAC address, right? This is where the MAC address kind of fits in. All of you are aware, but just, for all of us to be on the same page. Now, this media access control or the link layer control address is a 48-bit address. And this is how the header looks like, the layer 2 header, the complete header. It has 6 bytes of source MAC address, 6 bytes of destination MAC address, and then followed by the type of the packet and of course the payload, right? And inside the MAC address, how does it look? It is 48 bits like this with the organizational unique identifier followed by bytes which identify every unique device in the world uniquely. So any device that has to connect to a network will have a MAC address, right? So each one, if you look at your printer, your laptop, phone, camera, IoT device, anything, it will have like a physical MAC address that is etched onto the device. And this is unmutable. You cannot change this. Correct. If you change it, then it's a different device that it will pose as a different device. But it is unmutable for all purposes. Now, what is interesting is that because this is unmutable now, take for example, your phone, or your iPhones, or Androids, or whichever phone you're talking about, even your laptops. Say you go to like a public space, like for example, metro, right? You go to metro. And currently the Bangalore Metro doesn't have Wi-Fi, but say the metro station had Wi-Fi and you logged into that. Now, using your MAC address, which is unique and which is unmutable, this will the wireless devices that are there, or the people who are kind of giving you the free Wi-Fi service, could actually track you. So this particular image is from London Transport, where people are offered free Wi-Fi. So as soon as they enter the underground, they can track everybody who is going through these stations. Of course, they say that they don't track individual users, but just patterns of users and how they go across the station. But the point is that once they have that information, there is nowhere, you don't know where they draw the line, right? About where, till what kind of information they use for what. But this is an interesting map of the patterns of people walking across the stations. And they also can get information that what is the average time people take to walk from one point to another. So they use this for, for having, suppose the length of the say it is 86 seconds to walk from one point to another, they think it's a nice place to keep a cafe or a bookstore or something like that. Again, all of this seems very non-intrusive. It's fine, no harm done. They're just using it for advertisements, for cafes and things like that. Also, if you go to retail, if you look at a mall and say the mall is offering you free Wi-Fi, you connect to it, they can exactly track where you stand, how long did you go into a store for, how much time did you spend at which aisle in front of which product. All this is fine, right, for targeted advertising, for rewards perhaps, for marketing and everything. But still, at some level, it's an intrusion of my privacy. Right, especially if you have Gmail and you tell your friend about, oh, you know what, yesterday I moved my chair from the library to my room. Next day I get like a ton of ads for buying furniture. So things like this, I don't want things to be in my face, right? I mean, there is some kind of a line that needs to be drawn where you say that this is my information and this is, not available for public use. One more interesting thing that I recently saw was one of the universities, right? They had used this MAC address to track where all a person goes inside a campus. I'm sure all of you would hate this, right? I would hate it. So this person you can actually track each and every person saying that he went to the lobby, he went here, he went to the, cafe. For me, it'll be going to the chai point, 100 times, but I don't want anybody to know. So all of this is part of the tracking and the thing which is used mainly for business, but there should be limits in which, but the problem is that you don't know how you can limit the usage to only non-intrusive things, right? And again, how is all of this tracked? Because of this MAC address. And getting into the technical aspects of it, right? How does this happen? Whenever you open your phone and say you want to scan your the Wi-Fi networks available around you, probe packets are sent out, right? And these probe packets have MAC addresses inside them, and they are not encrypted. They are free in the air. So anybody who can capture this in the air, or the controller itself can exactly know which physical MAC address is kind of scanning for open SSIDs. And once you find an open SSID and you connect to it, then all the packets, all the data and everything that is going out of your phone is also going out as L2 packets eventually. And it has the MAC address in it, which is freely available for anybody to kind of capture. So this is the reason why anybody in the vicinity of that Wi-Fi network or the controllers of the Wi-Fi network themselves are able to identify these devices and collect a lot of information about these devices, right? So I don't know if you are aware of this Sting song. It's a very, very nice song. Every breath you take. So I just changed this to They Will Be Watching You with Wi-Fi. Anyway, so I found this really nice thing by Daniel on the web about, I don't think it's a question of why privacy matters at all. It does matter, right? It is in some sense a fundamental right. And I don't think based on what I buy or where I do or how fast I walk or where I spend most of my time in campus, anybody should make any kind of judgments about me, correct? So privacy absolutely matters. And then and if there is a way where this privacy is being compromised, I have to find all ways to make sure it is not there. So what do you do? Very obvious answer, correct? So how are they tracking me? By my MAC address. And if I don't even tell them my MAC address, then what can they do about it, right? So the easiest answer is to randomize this MAC address. So every time I connect to my SSID, I will not give my physical MAC address that is etched onto my chip at all. I'm just going to generate a random 48-bit number with different seeds. The seed could be a SSID or a time or organization unit or anything it could be, but with a different seed, I will just generate a random 48-bit number and I will offer it. So it doesn't matter, right? As far as the network connection goes, it is just a 48-bit number. I can give any number I want. It doesn't have to be that physical MAC at all. The whole protocol, the handshake that happens between your device and the controller and the switch and everything else will go as smooth as before. There is no change at all. I can connect, my L2 connections will be there. After that, my IP packets will go on it. My TCP, UDP, everything will be fine. So just changing this MAC address doesn't change anything in the networking side of things, but I get this added advantage of now nobody can track me. And this is one simple, like a cartoon thing of saying that, anytime I connect to a different SSID or connect multiple times, I give different MAC addresses, so you can't really catch me. So how do I know whether a particular MAC address is randomized or not? Because that's the first thing you do, right? Whenever you define a new protocol or anything of that sort, you always have to give an option of telling whether that particular MAC address is random or not. And the way we do it is this bit. This one means it is locally administered. That means it is randomly generated by that device. So if you see a MAC address, for example, in this case, if you see the second character in the MAC address, right? If it is either 2, 4, 6 or E, then you know it's a MAC address. Of course, here I think only this one is MAC. I just put some random numbers. So it just happens that this particular one is a random MAC and the others are not. So instead of E, if there was a 2 or a 4 or a 6, also it would be a MAC address, randomized MAC address. So that's how you know that it's a random MAC. Now, how did this whole thing about randomized MAC start? It's not new at all. Remember, I told you that when you start connecting to a Wi-Fi network, you send out probe packets and the probe packets have a MAC address in them. Now, what they started to do was long back, I think in 2014 itself, they randomized that MAC address. They didn't want to give out the actual MAC address of the phone that is sending out these probe packets to connect to a SSID. So this probe packets already use a randomized MAC address, and they've been doing it for a while now, at least 6-7 years now. So after this, right, the data packets, they were not being randomized. Once you finish the association with the access point or your wireless controller device, after that, when you start sending data, that you send with the physical MAC itself. Now, what they are saying, what lot of operating systems and device providers are saying is that MAC also will be randomized. Correct, and the way it is going to be randomized and the number of times it's going to be randomized is defined by different vendor or manufacturer differently. So, for example, if you let's come back to this slide. If you look at this slide, the Apple devices, for example, will eventually. So currently, if you take an Apple 14 device, every time you connect your iPhone to a wireless LAN, it is to a particular SSID. It will give you a particular random MAC. But if you connect again, then also it'll give you the same MAC, but they're going to change that in the coming year, where they will say that it's going to be time based. That means how many hours or minutes or whatever you want that MAC address to be randomized. So even if you connect to the same SSID, the MAC can keep getting randomized every, say, 5 hours. So that is like truly, randomizing the MAC, and it's also called rotating MACs. Because when you connect to the network, you keep rotating your MACs. You don't rotate as in you don't reuse, but you just keep generating newer MACs. Android 10, Windows, all of them. In Windows 10, you can already go and say that for how many hours once do you want to go and randomize your MAC. If you haven't seen it, and if you have any of these devices, you can go and check. So in Windows, it'll actually say on and off for use the random hardware address. I think it's default on. And iOS 14 also, the private address is default on. This means that it is going to use only a random MAC. And if you try to turn it off, it is going to give you a security warning saying that, are you sure your privacy might be compromised? And this in Android 10, this is by default. It uses the randomized MAC. If you don't want, you can turn it off. So this is how a lot of the manufacturers and devices are giving options to the users to protect their privacy, right? This is fantastic. This is great. Privacy is there, and you can, of course, if you go into a network where you trust the network and you're okay to give in your physical MAC, you're okay to be tracked, then it's fine. It's an option. But the main idea of this whole thing is the fact that privacy is a right, and if I want to disclose anything about myself, it should be in my control. Nobody should be able to take my information without me knowing it. That's the bottom line of this whole thing. Now, so what, right? So why is Cisco interested? Why are all these networking companies interested? Finally, because of course it's the MAC. It is like the basic L2 layer addressing that has been there for many gazillion years, and suddenly now we are saying that we cannot rely on it. So surely there are repercussions in all the different networking platforms, right? A lot of things that you do in network now suddenly kind of breaks down. So what are those things? For example, one very simple thing all these ISP internet service provider does is that, say your phone is not connecting, or even in a network, say in your campus, your device doesn't connect to something, and if you want to figure out why that is happening, there are logs, right? Hopefully there are logs somewhere. But then if there happens to be a network admin, the first thing he will look at is ask you for your MAC address and say, oh, let me see if I can track it. Let me see where your packet kind of dropped. You try to make this connection. You've come here, you got authenticated, but your packet has dropped maybe here because of this particular device that is blocking you. So how do you track all of those packets? By that MAC address. So now that whole thing kind of falls apart. There is no way for me to track it. So privacy is great. I've given you like this place where you can come in and you need not even tell anybody who you are. But now the network is also at a loss. The network doesn't know who you are, right? And how can I give you special policies and special treatment if I don't know who you are? So those kind of things. And many times, a lot of the products have, for example, they sell licenses to customers saying that you can use this product for 1 million devices. Correct. And how do they count these devices? How for me, what is a device? It is the unique MAC address. Now, say the same device comes in 10 times, right? With 10 different MAC addresses. I'm going to count that as 10 devices. My 1 million license is going to explode. I mean, going to be over quite quickly, right? And it's not great for our customers or whoever is using these licenses. They don't want to keep buying new licenses. Like this, I'm just going to put everything here and not talk about everything perhaps, but for example, DHCP. DHCP today, when you go and ask for an IP address, you also send your MAC address along with the DHCP request. The DHCP server will assign an IP address to you and you use it and say you get out of the network. You come back into the network and you ask for the IP address again. It is going to see that you had been allocated this IP address for that MAC address, and it will try to give you back that same IP address. Now that's gone, right? Because it doesn't know that you are the same person. So that IP address which was mapped to that random MAC address is now blocked, correct? So a lot of things like this. There is anomaly detection. For example, that you had connected a Raspberry Pi with a particular MAC address or a printer with a particular MAC address. Now, the Raspberry Pi is kind of posing itself as a printer. How do I know? Before, at least I would know that because of this MAC address, it belongs to a printer family, because of that OUI address that I told you, right? But now I have no clue. It's a random address. It could be anything at all. And many of the orchestration devices or your management devices of networks, which do visibility checks, which do health checks of different devices, how are all of them doing it today? Based on this MAC address. So we have taken this MAC address so much for granted that now when we start saying that, okay, you can come in with whichever MAC address you want, we are starting to see that different parts of the network are getting affected differently. Correct. And then, like I told you, the most important thing in a network when a user joins a network is how that particular user gets treated in the network. What is the quality of service he can be offered? What are the policies? Now, all of that, of course, many of the time it is also based on the IP address, but many a time it's based on the MAC address as well. Now, it's not traceable, so it's not trackable. So what do? On one hand, privacy is great. I gave you, your right to come in completely undisclosed. But now I want to treat you differently because you are an employee. I want to treat you differently from a guest, but I don't know how to do that, right? So these are all the different problems that we face in a network. I'll go into one particular problem in detail because this is kind of interesting. And here what happens is, don't worry about the jargons of MDM and all of that. It doesn't matter. This is a very simple case of a phone coming in and it wants me to authorize it. There is a network access control. So typically, how does it work? A device comes into your network. The network will go and say, can you authorize me? And I will authorize you, right? As simple as that. So same thing happens even here. But in this case, what also happens, I think there's some background.
तो वहां जाके अपने हाथों हाथ उसको समझा दो और अगर कोई दिक्कत हो तो उस समय हम तीनों ही एक साथ मतलब हमको कॉल कर लेना और उसको उससे भी बात करा देना.
Should we mute that person, please? Okay. Okay, going back to this, what happens typically is that whenever you log into a device, right? Say you go into a enterprise and you have your iPhone and you want to connect to that network. So what the network admins usually want is that your phone or your laptop or anything that you're bringing into the network run a particular version of software or an antivirus version or something like that, because they don't want you to come in with an old outdated antivirus and then introduce some virus into the network, right? So how does this happen? Typically, whenever the phone comes in, it registers all its compliance parameters. So, for example, what is your software version? What is your antivirus version? And all that. It tells it to a server. Again, like I said, don't worry about the nomenclature. It's not important. It's just the protocol we are talking about here. So I will tell that some server which is sitting there that this is the antivirus version I'm running. This is my software version of my Android, and all that, those parameters, it sends it to that server. And how does it know it's me? It's because of that MAC address, that physical MAC address that was there on my device. So based on that MAC address, I send it. And this server will have a table that will say, for this MAC, this is the software, this is this thing, and it is compliant, yes or no. Just a simple check, right? Okay, it's antivirus version 10.x and it's okay. Or if it's 9.x, it will say it's not okay, right? So it maintains that. Now, when this device does authentication with a network access control device, it sends its MAC address, right? Now that device will go and ask that server wherever you had registered, is this device that is sending me this info, this trying to register into this network, does it have all its compliance parameters fine? Is it running the right software? Is it running the right antivirus version? If it, then what does this do? This looks up its table and say, yeah, I got this MAC address and this seems to be fine. And it will say, yes, you're okay to come in, and this one gets authorized and onboarded onto the network. Very simple, right? With physical MAC, this was like a breeze. Now think of it, think of a random address case. This one has registered. When it registered to this mobile device manager, it was using a random MAC address, RMAC1. Correct? So it sent all its parameters, which version it's running, everything, but based on RMAC1. Now, after maybe it came in the next day, or maybe it connected to a different SSID, anything. Now, the MAC that it is going to use is a different MAC because I have enabled privacy. And the random MAC is a different MAC now. I send it, and when I send it, again the same thing. It's going to ask that server, do you know whether this particular device is compliant or not? Is it running the right version of virus check? And this server has no clue, because somebody registered with RMAC 1, okay, but it's asking for RMAC 2. I have no idea, so it will say no, I don't know, and it will fail the check, and it will not be authorized into the network, right? Such a simple thing, and now this will not work because I don't know who you are. Correct. Now, so what do you do for this? What is the very obvious answer? To move away from MAC addresses for all of these different functions of the network. Not an easy task at all, because it is so inherently MAC based. To move everything from a MAC address to something else is extremely difficult. But even if we move away, say, even if we move away from a MAC address, what is our main goal? Our main goal is to give privacy to that end device, but at the same time have a more secure way to identify that endpoint. And that identity should be persistent. It should not become like this randomized MAC. It should be trustable, and it should not be. It should be a constant, across SSIDs, or how many times ever I log in and everything. It should be easy to maintain it, because a MAC address was extremely easy. It was etched in your chip in your phone. Anytime you wanted it, the Wi-Fi supplicant would read from it and send it. Right now, if I want a different ID on my phone or on my device, it should be as easy. And the most important thing is it should be secure, and it should not be available for anyone to use. It should be just there for providing security aspects in the network, right? So the one thing that we have thought of, I'm sure if you can think about this more, if you come up with different ideas, please do share, or you yourself can write papers and discuss with your professors and see how you can come up with different ways to solve this problem. The one way that we have tried to solve the problem is having a unique identifier, which is not a MAC, of course, which is some unique identifier. The identifier itself does not matter. It could be anything. It could be a 128-bit GUID. It could be a UDID. It could be a host name. It could be a ESIM number, whatever you want, right? But the idea is to put it inside a certificate, an authorized certificate, which is issued by a certificate authority. And this certificate is put inside your phone, and it cannot be, or your phone or your device or any endpoint, and it cannot be manipulated, it cannot be changed, it cannot be copied, and it cannot be, there's no man in the middle who can just pick up that certificate and read the contents, nothing. And whenever you use the certificate to do authentication and the packets go through the air, you won't even, there is no way for somebody to pick up these packets and get that information from the certificate. So we thought this was the most secure way of doing it. Now let's see how this certificate, how it will change things, right, if we have this unique ID. So now what will happen is your MAC address is still there, of course. MAC address you have to have. There is no way around it, because all our protocols, our L2 is all defined based on that. Now, that will continue to be the networking part of it. Now, we also introduce a certificate issued by a valid certificate authority. It could be any device vendor, it could be the enterprise, it could be anybody. So it will generate a unique ID, put it inside that certificate, and that certificate will be inside that device. Now, when I send information about myself, I won't use the MAC address anymore. I will send all my compliance parameters using that unique certificate, right? And then now, if you remember, before we used to do a TLS based, 802.1x authentication. That is, .1x authentication just requires a username password. It's the simplest form of authentication. But here now, because we have a certificate, we need to do something called a TLS based auth or a certificate based auth. How is this? This is like a handshake, right? You establish a connection and then you send that certificate over a secure encrypted channel. Now, then once it gets the certificate, then the Network Access Control Authority can read from the certificate because you would have exchanged your keys. And it gets that unique identifier from that certificate, and now it uses this certificate to ask that server whether this is compliant or not. Now it's the same unique identifier that you had used, so everything is fine, and it gets that certificate right back. Right. So this is one solution that seems to solve many of the repercussions that you saw, right, in the networking world. Now, another interesting thing now is that for a while now there has been something called a eSIM or an electronic SIM, where you don't even need to have a physical SIM installed on your phones, right? It is a writable portion of your memory which can be etched with the eSIM number. This is by connecting to that particular eSIM provider. They will give you the eSIM, and so this is very useful when you want to move from one provider to another. You don't have to keep switching your eSIMs. So what we did was we did one proof of concept interestingly, this eSIM has a certificate inbuilt in it, and that eSIM number is written inside that certificate. So it just worked out very well. So when we did a POC with this eSIM, the same thing happened. The eSIM already came with a certificate and a unique identifier embedded inside it, which was the eSIM number. So we used that, and same way, instead of the unique identifier now was the eSIM number. So you could have that phone or your laptop or a device send that eSIM number from your certificate. Same. The flow doesn't change, but the interesting thing is that we could leverage the eSIM certificate that they were using, and this was a company called GND, and they make eSIMs for them. So if you want to go look it up, that's another interesting space. The interesting thing about eSIMs is it not only gives you a certificate for an identity like this, but it also gives you a way to probably down. So if I go to a particular enterprise or maybe a country even, I can have a definite profile get loaded onto my phone. So everything kind of comes onto that, and then I can get onto the network, right? It's a very interesting concept. You can check that out. So this is one more thing. The other one is that in this case, what we saw was that we had like a separate device manager here doing the compliance check, right? Sometimes it can happen that you don't have such compliance check, but you can do a three-way handshake just like this. So in this case, I know there are a lot of numbers here. I should have animated it, sorry. But the way this works is that there is a phone. Initially, there is no certificate. First, you do just a normal .1x authentication with just username and password. Here, what happens is this network access control, any authority, it could be anything, any device that authenticates that device endpoint can generate a unique identifier. Could be a GUID, which is a 128-bit number, and it also puts it inside a certificate, issues a certificate, and downloads that certificate onto the end device. Now the end device has the certificate embedded in it. Now when it wants to connect to the network, it does a TLS based auth or a certificate based auth, presents this certificate, then this network device will say, okay, because of the certificate, you're authorized to my network, and now I know who you are because of that unique identifier that I saw inside your certificate. So this is very useful for devices in the when you say BYOD, right? Bring your own device. Say you just come into a Starbucks, you want to use that device. This is one way to do it. This is the This is one solution that I was talking to you about, right? Now, like any solution, what is important is that it has to be standardized, because otherwise everybody will be doing things their own way and there is no consensus, and it's better to do things in a similar way, so that it kind of, the solution is useful. And if you want to do some kind of a if you want to come up with some solutions on top of this, right, then it's more useful if many of the devices follow this pattern. So in terms of standardization, what we want to do is that today we store that unique identifier inside the certificate, inside something called a subject alternate name. That is there inside every certificate even today. It's called the SAN, and under the URI we store it. So we want to standardize that, so that the certificates can, all the certificates, whenever it's issued, has a placeholder for that unique identifier, right? We want to do that. And then we also want that unique identifier to be very, very flexible. So, for example, I don't want that somebody might want, say Starbucks will want that ID to be like you did, for example. And if you go to an enterprise, say Wipro or TCS, they want it to be a host name. So it could be anything. The whole idea is to make this unique identifier as flexible as possible. But as you bring in flexibility, you have to add metadata into that identifier to know what it is, right? So we should have something called a source, that is who generated this ID and what kind of ID is it. For example, if it's a host name, then you can have something like this. Another important thing is that once I have this identifier, I need to send it to my wireless controller as well, right? So we won't get into this in that much detail, but one other thing we are working on is that once this identifier is there in the authorization device, it can send it to a wireless LAN controller using an access accept. But of course, there are all these things to consider about whom you want to share this unique identifier with, right? That's a completely different topic. But this is, in essence, the whole idea of, privacy, and why MAC was used to violate this privacy, and why the MAC was randomized so as to protect the privacy, and what the networking side products and devices and protocols and everything have to do to respect the privacy, yet treat these devices like how they did before. There should not be any interruptions in the way devices get policed or given quality of service or given access to different resources in a network, while giving them and maintaining their privacy. So that's the whole idea. I think the main intent of the talk is to introduce you to this subject so you can think about it more, and given all your fresh minds on this topic, see if you can come up with different ways to honor privacy, yet kind of identify that device and provide security, provide networking aspects and all of that to it. So that's where I'll conclude my talk with this. You can just read it. But if there are any questions, I can take them now. I think everyone's on mute.
So you're going to take it?
Go ahead.
You're on mute.
Yeah, please go ahead.
Okay, so is there any question from anyone?
Lakshmi, he is Dr. Ajay Pratap. He is co-coordinator of the program.
Oh, hello. Hello, sir.
Right.
Okay, let us take some questions from audience. Is there any specific question from anyone, or you can ask any question right now related to the subject? Anyone?
Sure. And if there is none, you can always reach out to me later at any point.
Yes, in fact, if they are really keen and particular about working in this area, they have to reach out. So we will, in fact, we have already announced that this is not a mere talk. Whoever wants to pursue it further, the experts will remain connected. It's a way by
Sure.
which we are forming the team. So, of course, connecting at a later stage. Even we and many other faculty members would also look forward to connect while
Surely.
effectively deploying IoT facilities, IoT networks for various
Correct.
applications. So
Sure,
that's
sure.
wonderful.
Yeah. And also, I want to mention that there is a standard body called Madinas, which has been introduced just for this. It's open for RFCs and drafts and papers. So it's a good time to get into this and explore.
And probably you are a member of that group.
Yes.
You are contributing in that group,
Yes.
right? Yeah, wonderful. Very good. So I think, Ajay, we can applaud the success of this talk. So
Sure.
thank
I
you.
hope it was useful,
You
but
have
do reach out
delivered
if
a
you have
wonderful
questions.
talk. This
Thank
was very well and very easily explained, although the concept is quite typical, and especially for at the level of hardware implementation, it is much more difficult.
Yes.
Considering real-time presence of this. So, okay, thank you very much for a
Thank you.
wonderful talk. So, dear participants, let's stay connected for the next talk. Okay, thank you very much, Lakshmi.
Thank you. Thanks,
Thank you so much.
everyone. Bye.
Thank you so much. Bye bye.
Bye.